There we go. Continuing with 5.2. All right. You guys had fun on Monday. Maybe? Yeah. So the Greeks, if we think about the Greeks thought of triangles within circles a lot because they thought about chords. If you think, remember chords in geometry? String a line through the circle from one end to another?
Yeah, chords.
Chords or chords, okay. Yes, that's right, chords. So what happened was the Greeks always thought of those things. Yeah, they would plug oh, that's right, from geometry. How about this little guy from geometry? Do you guys remember? Like if you string a triangle all the way across right here, there's like theta and the relationship to this little piece right here, which we call S, right? And there's something like half of that angle is actually the angle on this side, or something like that. All these different theorems, and that's why you guys did a whole bunch of theorems with circles and triangles and in geometry. Do you guys remember geometry? Okay.
Yeah.
All right. Well, let's go on. So.
I have geometry credits.
So we've developed two formulas so far. So the sum formula for cosine and the difference formula for cosine. Are we good? Let's see. Last time we talked about getting the cosine of 15 degrees. I think, is that where we left off? I think so. Talk to me. This is exercise 1. Was it 1 or just 1A?
It was 1.
It was 1. Okay. Exercise 2. Let's go for it here. Should we do another one here? Let's see. I'm thinking. Oh yeah, that would be a good one. Exercise 2. Can you give me the exact value of cosine of 105 degrees? Right there. Did you complete it this time? I did. Okay. This thing is taking a while to, yeah, the hair. Awesome. All right, all yours here. So first things first, you can either think of two angles that add up to 105. You can think of two angles that subtract to give you 105. And there's going to be an infinite amount of combinations. You just guys give me two. That would work.
45 and 60.
45, 60 is good by me. 45 plus 60. Add them up, we'll give you 105. And again, this is awesome. We're going to get exact values for angles we have not known before. That's the point here. And let you guys try it yourself. This would be 45 plus 60. All right, if you want to be very specific here, you're going to keep on with the degree value there. There's a degree symbol for notation. So a few things here. Depending on the angle that you choose, your answer might be slightly different than what the textbook answer is. So we'll talk about it in just a bit. So all yours. Give you guys half a minute. Try it yourself. Look at the previous example. See how far you can get. I'm going to start as well. That's done. So the formula that I see up there is to the sum formula, which is the top one here. So how about cosine of 45 degrees multiplying cosine of 60 degrees minus sine of 45 degrees, sine of 60 degrees. That's cool. Let's see, what else did we talk about yesterday? Oh yeah, that's right. Whenever you get a ratio of 1 over root 2, which is what your unit circle says, you can just change it up because it's the exact same thing as root 2 over 2. So those two, in fact, I'm going to just put equal sign. Those two have the exact same value. Choose the second one. It's a lot easier to do and to work with here. All right. Talk to me, anybody. Cosine of 45 degrees.
Root 2 over 2.
Like that. Cosine of 60 degrees. Root 1/2. I'll go with 1/2. Boom. Let's see. Boom. Awesome. Okay, and with that, let's see, multiply that together, square root of 2 on top, 4 on the bottom, and root 2, root 3 makes root 6 as a multiplier, and voila. So that's usually our final answer there. Good, bad, ugly? Kind of, sort of, all three. Okay.
Wait, so can you simplify it at all at the end?
We usually don't. We usually leave it like that. You could pull out a square root of 2, I guess, out of that. It'll be 1 minus root 3. So, but we, in mathematics, if you do this, which that's what's going to happen, you still won't be able to cancel these off. So because you don't cancel, why do it? And then there's a debate among mathematicians. The question is this right here. Is this simplified or is this simplified? They get together for math conferences, they arm wrestle who wins, and then by that, they go with whoever won. Okay, let's go backwards here. Exercise 3. I think, yeah, the directions are like this. Write as a single trig function. So I have cosine 5x. Into a nice looking 5. Cosine 4x minus. Again, pretty easy. Backwards, all yours. And talk to me when you have the answer.
Do you want us to just like tell you what we think the answer is?
Absolutely.
I got cosine of 9x.
I totally agree. Cool. Okay, that would be the same thing as cosine of 9x. It's going backwards on our formula. Again, just need to figure out which formula you're working with. You're working with that formula there. That's the 5x, that's the 4x. So when you bring it back to this one here, it's really just the addition of those two to give you the 9x, just working backwards through your formula. Are we good?
Can you explain that?
Absolutely. So when you look at this one right here, you're saying, oh, you know what? That's actually a formula on the right-hand side already, right? So the question is, which formula is it? And then what are my angle values? And so as I look at this, it's going to be the top formula. And then that means that A has to be the 5x, B has to be the 4x. And because you're just plugging it into really the formula itself right there. And you're just trying to get the simplified version here. So cosine of 9x. All right. Again, please ask me the questions. That's what we're here for. All right. That's enough of cosine. Actually, no, one more thing, cosine. Exercise 4. Prove the following. Okay. Right, talk to me here. Let's see. Before we get there, let's think about this a little bit here. The sine curve. You guys remember the sine curve? Like this. Oh no, even better yet. Hold on. I'm gonna do it differently. What's the period for cosine?
2 pi.
2 pi. That's right. Because whenever we graph stuff, we would go like this, and then we'd set this guy to be 2 pi right away, and done. And we learned it from the graph itself, right? We graphed it, like, oh yeah, that's cool. And then we know it because when you swing around the unit circle, it takes you 2 pi to get there. We've never proved it. We've never algebraically said, oh, this is going to lead to this is going to lead to this here. So you guys get to prove this. Prove for me that cosine has a period of 2 pi. And the way we prove it is this right here. Prove that is true. So that means if I add 2 pi to the angle value, it's still going to give me the same thing as cosine. Pretty cool stuff, I think. So this is, intuitively we knew that. Intuitively, because you're going to just start doing rotations around the unit circle. That's fine. But now it's an actual proof. And exactly how we used to do before, right? The right-hand side is pretty simple. It's just cosine x. It's the left-hand side that could use a little bit of simplification. Now that we know the summation formula for cosine, I think it's going to be like this. Cosine of x times cosine of 2 pi minus sine of x sine of 2 pi. Everybody agreed, disagreed, maybe sometimes? Awesome.
But because you're plugging it into the formula.
And that's cool because we also, on Monday, we actually proved the formula, right? So we have really hard proof in a sense for it here. Okay. Cosine of x times 1, is that right? Minus sine of x. Oh, there's my 0. And then I got myself.
Wait, where did you get the 1 and 0s from? Oh,
On the unit circle.
okay.
And perfect. We just proved it. Now, beyond a shadow of a doubt, we know that the period for cosine is 2 pi. Done. Love it.
Why would you write period as x plus 2 pi?
Mhm.
Is that going back to the graphing formula we learned?
Let's see. Two things here, yeah. So from the graphing part, we know in graph-wise, whenever we set it up, it's always 2 pi, right? In order to prove something is the same, or something is repeated, what we do is we add a 2 pi to it. So here's what it is. It says name any x in here. Let's say x is right here, right? And so we're saying if you add 2 pi to this, you're going to wind up in the same exact y value place. If that makes sense.
Oh, okay.
Right. By adding 2y, it doesn't change the y value. And then because x is arbitrary, it could be anything. We've just proved that whatever x you used, as long as you add 2 pi to it, it's going to be the exact same thing.
And is that the same reasoning like behind when we did like the y equals a cosine bx minus c? Is that just basically the same thing that we just did? We just wrote like the standard cosine curve and then
But as we were graphing it, we never proved it, right? We just graphed them.
right.
Right. You could see that one graph lines right on top of the other one, and that's cool, but it wasn't an algebraic proof yet.
Right, but that one that we just did, that's basically what it is. It's just the period. Okay.
Yeah, something that we've been doing for quite a while. Yeah. Even from like the first chapter or the second chapter, because we said that, hey, you know what, if you rotate over one rotation, you're going to get the same values. Okay, we good? Dun, 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 dun. Let's go on. Cosine was fun. How about this? We need to somehow get it to how do we want to do this here? Oh yeah, that's right. I want to prove this now formula. Sine. How in the world do we do that? What is that? So let's think about what we know. Again, think about it as a mathematician here. I do have two formulas that I know. What is the relationship between sine and cosine? Anybody? I don't know. Let's go back to our graphing here. Let's kind of think things through here. So sine function is like this, is that right? Cosine function is like this. Two pi, 2 pi. Would you guys say what? Would you guys say that if we were to go this way, right? That would be the beginning of cosine. So if I were to divide this up, this is pi over 2. So there's a little relationship. If I take sine and I add if I go what to the right, is that right? To the right, which is minus. So sine, so we've got x and pi over 2. Everybody okay is using it as 90 degrees as well? Can I do this? Talk to me, see if this makes sense.
Where did the 90 degrees come from?
90 degrees comes from pi over 2 being the same thing as 90 degrees.
Oh,
So again, let's just kind of mess with it for a little bit here. So if I move sine over by 90 degrees, I essentially get cosine. Talk to me if that is true, or does it still feel like a Monday morning? So let's see, so sine of x minus 90 degrees is equal to cosine. Okay, I go with that. That does not help me though, huh? In fact, I probably have to go maybe the other way. I think I'm just trying to figure out how to connect. I have rules for this, don't I? I have rules for cosine of a plus b, cosine of a minus b, right? So I'm thinking maybe I go the other way. Maybe I'm thinking I'm going to go this way. What do I do to cosine in order to get me back to sine?
yeah.
Add pi over 2. Okay, so see if this will work. Guys, talk to me here. This is cosine of x, and so if we were to go back over here, right? If we started right here for cosine, it'd be cosine of x plus 90 degrees, because remember with the horizontal stuff, we always go backwards, right? We always go the opposite of what it goes. So tell me if you guys agree with this. Is that the relationship we have? Okay, I see some people saying yes. Okay.
I was nodding and all the no. Like, so I can't be nodding.
Okay, let's take this one. Again, this is just playing with stuff. So I'm going to go over here and see if this will work. And if it works, that's great. So cosine of a plus b, that's essentially going to be my x down here. Are we good there?
Wait, which X? Sorry.
Yeah, it's going to be this little x
Oh,
right
okay.
here. So if I do this, I should be able to bring it together to cosine and see. This is be a plus b, that's my little x, right? Plus 90 degrees. Does that work?
You're saying A plus B is the X, not just A?
A plus B is the X, And again, I'm just gonna try it. Does that, you guys talk to me here, does that sound, look okay? Okay. So here's, let's do this here now. How about this? We're gonna formulate this as the 90. Let's bring it over with the A. Let's have the B all by itself at the end. So we're gonna bring the 90 over here this way. So let me write that as a 90. Okay, so I'm going to treat this right here as one single angle measurement. Are we good? And I'm going to treat this guy as another single angle measurement here. Oh, hold on. Don't we have the sum formula for cosine right there? So I'm treating this guy as one piece, and I'm treating this guy as one piece. And give me, now it looks like this, doesn't it? Doesn't look like cosine of x plus y, right? That's the x right here. That's the y there, right? It's the two angle measurements. Good. Yeah.
Could you just do, like, distribute the cosine? So like do cosine of A plus B plus cosine of 90 degrees, or does that not work?
Huh, that's interesting. I think that's the question from Monday's class, right? Class, talk to me here. Can you distribute the cosine to here and then to there? I think that's where we started off on Monday's class with. Remember we said, hey, is the cosine of 60 and cosine of 90, can that be just distributed across?
Well, it can't be distributed across the equal signs. Can't it be distributed on the same side?
I don't think so.
Wait, also, why is A plus 90 degrees one angle? Like, could you technically make B plus 90 degrees?
Yeah,
one?
sure.
Okay.
You're gonna have to choose one of those angles.
Okay.
Okay, good. Let me go back over here. So we're gonna choose, what we're doing is doing this right here. We're going back over here. And we have an addition formula, right? So what we have is we have this piece right here, that guy, and my little a right here is technically 90 plus a right there. I'm going to use it as one single angle formula. Then the b value is just b by itself. That's the normal one that we do anyways.
Why is it that you need to add 90 degrees to either A or B?
Perfect. Because we are trying to set it up so that it's in terms of sine instead of cosine. We're trying to prove it for sine. And the relationship between sine and cosine is they're 90 degrees apart from each other. And you guys, please ask me the questions. Absolutely. This is part of it here. Okay, so I'm going to go with this guy here. This should be now, let's see, that's first angle, that's second angle. Let me go back to see my little notes here. First angle, second angle. So I'm going to go cosine of first angle times cosine of second angle, subtract sine of first angle, sine of cosine angle here. So see if this makes sense, guys. This will be first angle, second angle, is that right? Minus sine. Hey, there's my sine stuff. First angle, second angle. Good. Does that work out? What do you guys say? Does that make
So
sense?
why aren't you adding the cosine B?
Oh, because
Great.
you're just plugging A and B into the formula?
Where am I at? Where am
It's
I at?
like cosine A plus 90, that makes sense. But then when you do plus cosine B,
Oh,
Let's
Because the
go.
formula is you multiply.
yeah, we're just
Formula.
pretending
Oh,
A
we're
plus
using that
90.
Yeah, we'll use that formula because we already established this formula.
okay.
Oh, I see some stuff. Tell me if you guys see some stuff.
So we're trying to make the right side look like the left side. Am I incorrect?
We started off here.
Yeah.
So we start off sine of a plus b. Have no clue what that is.
We're just trying to
Wait, so can
simplify
you-
it to where it's like a formula that we have for cosine.
Correct, yeah.
So could you turn the cosine of a plus 90 degrees into sine?
Oh, absolutely. Here's your relationship, guys, right here, right? Boom. There's a relationship. I'm going to change this back to, and notice the relationship is x right here, right? And x over here. So this is just sine of a cosine b. Awesome. Anything else? Okay, we got ourselves a little problem. Sine of a plus 90. What in the world is that going to be?
Oh, is it negative cosine?
How and why would you say, Amaya?
Because, okay, this might be completely wrong, but sine of x minus 90 degrees equals cosine of x.
Ooh,
We
okay.
have sine of a plus 90 degrees.
Let's verify that. Let's look at a graph real quickly here. Sine of a plus 90 degrees. So this is what we have for sine of a, right? And if you go backwards 90 degrees, right? Because plus 90 means you're going to go to the left. So if you go backwards, it's going to go this way. And here's our starting point. Does that look like an upside down cosine curve? Absolutely. So we have this little relationship that sine of x plus 90 degrees is equal to negative cosine. Hey, that's cool. We just developed that relationship based upon a graph. I like it. I think we can plug it in. So we got this guy here comes in as negative, bless you, cosine of what? Cosine of A. Sine B, there's no change there. And so I think I got it here. This is sine A cosine B plus cosine A sine B. Are we okay? I know we can do a hoo-hoo. We just developed a different formula. Now we just developed a formula for the addition of two sine values. That's awesome.
Okay.
You guys are
Oh, wait, so that
pretty
is
cool,
the
terrific.
formula?
We just developed it. We're done.
I wasn't sure how we would know how we were
Yeah.
done because it's not like we're like able to identify and anything like that.
It's not like what is 2 plus 3? 5. Oh yeah, okay, we're done, right?
Okay, so I recognize that I'm the one who said it was equal to the negative cosine x, but why is that?
Sure. So the sine curve is right here, right?
Yeah.
So if we were to take the sine curve
Mhm.
and technically start at 90 degrees earlier, right? So we go like in a sense a quarter, right? Quarter of the way.
Yeah.
And so as we look at this graph, we're saying to ourselves, okay, hold on. So that means if we just take negative cosine, right, it's going to look just like that. Actually, I should put a little higher. Right, that now matches the starting point to be right here.
Oh, okay.
And that's just a cosine curve. And if we were to graph it with a different marker, there's your start of it.
Okay.
So we can use graphs just to sort of see the comparison between them.
So
Okay.
you're
That
saying
makes sense.
negative 90 degrees is moving it to the right,
Mhm.
which changes it from a sine to cosine because of how it's positioned against the x-axis.
And so when you're doing like sines and cosines of things in parentheses, you don't like distribute at all, like just like don't do it.
Correcto. So here's our formulas, and we have to develop still the tangent formula. So you can't distribute the sign. What you do is you have to use this formula to get you there. All right. I think we can do this here. 1, 2. Can you guys prove to me, before we go on, can you guys prove to me the subtraction formula for sine? Give me the difference formula. Let you guys think about it. What are you gonna do? Any thoughts?
Would it be sine A cosine B minus sine A sine? I mean cosine A sine
Almost there, almost there. So we have the sum formula. We got that one right. And now I'm going to develop the difference formula for sine. So I want to say, what's sine of A minus B? How should we do that? A plus a negative B? Yeah, that would work.
Switch the sign.
We can switch the signs because A minus B, let's develop this formula. Let's do this one here. A minus B, it would be the same thing as, because we know algebra rules and pre-algebra rules. We have that on our hands, right? That means the same thing. It's not like just because it's inside a sine function, all the algebra rules go away. Algebra rules are still there. So all yours, can you give me the formula for the difference formula for sine? Something about even functions, odd functions is going to turn out to be a certain.
Yeah.
So we just developed the sine formula, right? We just do the sum formula. Sine of A, then what? Previous page or previous slide.
Cosine.
Cosine negative B,
Yeah.
right? Because we're following, here we go. We were just following this formula here. Only change is this little b is a negative b this time.
So it doesn't change both the A and B negative?
Because we're just trying to figure out the subtraction between the
because
two.
now- Yeah.
Because A is still positive. Yeah, we just switched the B to negative. Cool. Sine of A, cosine negative B, and talk to me, plus or minus.
Minus. Oh, wait, plus, because
Plus.
it's,
Yeah, it's still the addition formula.
Okay, and we have then, it switches, right? Those in trig functions switch now on you. So then it becomes cosine of A and sine of negative B. I think we're cool like that, okay?
so would you be able to start saying sine of A minus B equals cosine of A minus B plus 90 degrees? Or is that different?
You could do it that way, the longer way to do it. Why do it the longer way when you already have developed a formula for sine?
Cool.
And you could just change the sign.
Well, making things harder.
Oh, that's funny. When I say sine and sine, I mean two different things, huh? Yeah, sine. Sine, sine. Okay. Cosine of negative b becomes
Oh, cosine would be.
cosine of b. It's an even function, therefore the negative sign drops out. That's cool. And I guess we should think of this one here. Plus cosine of a does not change. Sine of negative b becomes negative sine of positive b because it's a odd function. I think we got it, guys. This is so cool. We're developing like new formulas in trig. Never seen before. Boom. There it is. We've just developed the difference formula for sine. Is it going to help us? Yeah, it's going to help us later on.
Wait,
Okay.
wasn't that what I said at the beginning?
Maybe.
Yeah.
And now we have proved it. So now we don't just believe Corinna.
I just believe in it.
We have a skeptic in the house. Okay, so now what we need is, are we good? Everybody wrote it down?
Yeah.
And let's keep on going here. Let's do this here. I need to figure out. I think we're ready for this one. Give me the addition formula for tangent. Give me the difference formula for tangent. And in fact, we'll do let's do a friendly competition. This side of the classroom, you guys go for it. You guys have the addition formula. This side has the difference formula. Ta-da-da. All yours. Think about it. You guys can speak out loud. That's fine. Like, hey, how in the world is this going to work out?
Okay, so,
I appreciate the
wait, could we just turn tan into sine over
Yeah,
cosine?
Okay, you have to prove it. Let's see if it.
If you see sine over cosine, then it's sine of a plus b over cosine of a plus b. So that we can just write it all the way out, so like.
Without the
sine
textbook,
of a
without
plus
the,
b
without
equals
Adrian's textbook.
sine
They're unrelated.
It's just a coincidence.
Yeah, exactly.
Yes, please.
Cosine is cosine A, cosine B, minus sine A.
Okay, and now we need to somehow simplify.
Well, we can.
But I can prove your formula.
Oh, wait.
Yeah.
You can't prove
see?
anything, but I
See what
have
I'm
multiple
saying?
proofs because I can hear them.
Ideas? Now we're stuck. Sine A cosine B plus cosine A sine B over cosine A cosine B minus sine A sine B. Oh my gosh, I know.
What he does is he just.
Maybe
goes
that,
default,
but I can't, how else?
Yeah, I
Leaves the
feel
next
like-
digit of pi on the other body.
Are we stuck yet?
Yeah, we'll figure it out.
Just like a mathematical genius.
Maybe
Yeah.
He calculates the amount of body. That's all. 3.1415.
Because they're multiplying the wrong thing.
Of the body.
Let me write it out for you guys.
Oh. Yeah. And then you have to read the equation behind.
Is that it? Is that just as simplified as it gets?
Because we need to put it back into.
It's got to get more simplified. Wait, yeah, this is, okay, we're good. This is what we did.
Okay, everybody good with this one? It just how it changes
wait,
to
that's
sines and
it?
cosines. Next, eventually it's going to have to be over here in tangent, right? So let's expand this out because this will be easy enough here. I think this is sine A
Okay, we were doing that.
cosine B plus cosine A.
Yeah, I was trying to say it just involves ratio.
But then how do we get
Why do we listen to
this?
you?
That's where we get stuck. That's why the competition was kind of not fair.
Did we get past this?
In just a bit here.
My brother, because you were saying the same thing that Adrian was saying, so I just assumed that I should.
All right, you should have got stuck here.
Yeah,
Yeah.
let's
Because you don't listen to it because you shouldn't listen.
Did we win?
Grant, let's get started. So you should have probably got stuck here if you're doing the sum formula, unless you have the textbook in front of you. Then by magic, osmosis, you.
Okay, you know what?
I do.
Literally so rude.
It's called using your sources.
Exactly.
The character trait, resourcefulness.
Work smarter, not harder.
So then the question becomes, what do I do? What can I divide by, really, in order to get back to tangent here? And so the formula has taken on different variations, but essentially decided upon the fact that we will just divide by. And so this is sine of A cosine B. And we're going to divide everything by cosine of A cosine B. And the reason for it is because if you see a sine there, if I divide everything by sine, if I divide by sine A cosine, sorry, sine A sine B, I would get cotangent out of it. right? Because then it would have a cosine sitting on top of a sine.
Wait.
See if that makes sense.
Sine?
Yeah, sure,
Yeah.
sure. So the question is, where do we get this from? And we get this from out of thinking all the way to the end. If I were to divide, let's say this first one here. If I were to divide this first one by, let's say sine. Sine A, sine B, what happens here? Those go away, is that right? What's cosine divided by sine?
Cotangent.
It's cotangent. So I'm gonna get cotangent. I don't want cotangent out of this. So then how about if I divide by cosine A, cosine B? Now these guys cancel, right? And am I still in tangent categories? Absolutely.
Where does the sine A over cosine B come from?
Oh, it's this little first piece right here.
And why can you do that?
Uh-huh. That's cool because we can always multiply through by 1 or divide through by 1. Because we're gonna do it both sides. We're gonna do it here on top. And let me just write it in here right here. And I can do it on the bottom. So technically what I've done is I'm dividing everything through by the same thing. Let me just write it in and then we'll deal with it in just a second here. Scary.
No.
It makes sense to me, I just don't know how I would think to do now.
Yeah,
Yeah.
agreed.
Like, this would never.
Occur to you, yeah. That's okay, because you're supposed to get stuck right there.
After years of studying trigonometry.
SAT's like, okay, guys.
Now that I know you won't be able to figure this out on your own, I will do this problem.
And it's time, have fun.
So you have maybe 4 minutes left.
You will fail.
And you won't get into the college of your choice.
No college.
Your life will be ruined.
Like,
We'll get a job, you'll starve, you'll die.
Okay, let's go with it here. So we say,
One that you don't like.
You just have to break it.
are we okay with dividing by cosine A, cosine B everywhere?
Sure.
Is that okay by saying that we're technically dividing by 1?
Yeah, that's fine.
Because we're dividing the bottom by the same thing as the top. It's almost like when we do fractions. Oh, the same thing here, 6/8, right? What do you usually do here?
I know.
Reduce. You simplify. What you're doing is you're dividing by 2, you're dividing by 2.
Yeah.
Essentially what you're doing.
Because the denominators in both cases, even though, like, I was thinking like, how does that work? Because it's a denominator and denominator, but it's because the denominator is
Yeah.
technically still the numerator.
Yeah, like
Yeah,
6 over
still,
8.
the ratio
my
is still the same.
brain
Yeah,
can
it
maybe
kinda-
figure out how to do that.
I know why it works, but kind of like trying to think too deeply into it hurts my brain.
Figuring out a
Yes.
problem within a problem.
Yeah. It's a fraction.
So let's go. I think we're almost done here. So let's cancel off the stuff that's the same. So sine A over cosine A, isn't that tangent A? The cosine of B is canceled. This one is going to be cosines cancel, leaving us with tangent B.
And wait,
Wait.
Over 10, wait, 1?
over.
Yeah. it would just be-
1,
1
Over.
1, okay, awesome, minus.
One
Tan
Tangent
A, tan B.
That is so cool.
Oh!
Weird.
That is weird.
Okay. And we just have a couple more problems to do off of 5.2 here, so we'll finish up on Friday. But let's do this here. Let's at least develop this one here, real quick here. Tangent is if you did the division one, you could have done it by sine of A minus B over cosine of A minus B, right? You can go back and do it this way if you like. Easier way. Anybody with an easier way?
Wait, so that's just the proof, that's the.
That's the proof to get us to the addition formula. And then you could have done this. You could have done this the same way that you did this right here. It's just thinking through the
Or you
problem.
can just reverse the sign.
So you just
Or-
make it a negative b in that case?
The easier way, absolutely. You just reverse the signs here. And can you guys give me that one? That should be an easy one to do. Let's develop the difference formula for tangent. All yours, go. Tangent, even function or odd function?
No, it's the one sine is.
Yeah,
Yeah.
cosine is like the only happy even one.
Yeah.
Yeah.
So I always think back to this right here. So cosine is even because when you go across the y-axis, this side and this side is exactly the same. That's what makes it an even function.
Right.
Sine is an odd function because it does that. It's the flip. As you just think of this right here. See, it goes up here, then it goes down here. So it's the flip of it here. What does tangent look like?
Just sort of like freaks out and then mine.
Okay.
Yeah.
It's like, yeah, that thing.
It sort of
It's
just.
sort of just freaks out. Okay.
freaking out, like I don't want to.
So I think tangent is an odd function. Is that right?
Yeah.
Because they're not exactly the same on both sides. It's not a mirror image. One goes up, the other one goes down. Okay, so
What the signs, right? Yeah.
so let's plug it in first here. Plus tangent of negative b, 1 minus tangent of a times tangent of negative b. And tangent is an odd function, so whatever gets out of here is gonna be tangent a, that's gonna be a minus tangent b. And this will be 1 minus minus, because that little negative is gonna go out in front. And so voila, we just developed the difference formula for tangent. Phew. Okay, got a couple of more problems to go just as exercises, but we've developed all 6 of them. We're done. We good? So you should be able to use those on the homework. Go from there. In fact, I forgot to check your homework today, huh? Shucks. So 5.1 homework, I did not check. I'll check it on Friday. We good?
Do you think it would make more sense, since you're gonna be checking it more regularly, if we also go over homework questions?
Sure,
for each
absolutely,
chapter
yeah.
instead of all the end? 'Cause I usually forget what my questions were and when we're reviewing everything.
So bring homework questions on Friday. We'll do part of that. We'll do that, and then I'll check your homework. And then we'll just do the last few problems of this section as well.
So do you think we can start the homework and pretty much understand?
Oh, yes, correct.
Okay.
You should be able to start the homework for 5.2.
Can we wait until after class